so we already have done composition of functions. We covered that in class together. So we're going to go ahead and skip ahead to these problems right here in our notes. Feel free at any point in time to slow down or pause this if you need to. So first thing we would do is look at these two functions, quadratic right there, linear there, and the domain is all real numbers for both. So we always want to pay attention to that, how the domain works. So when you add these two functions, you're basically just adding like terms. All right, so now let's go ahead and subtract them, f minus g of x or f of x minus g of x. So that would be the quadratic, 3x squared plus 4x minus 5 minus 2x plus 9. And if we just add up our like terms, we get the 3x squared stays, 4x minus 2x gives us 2x, and then negative 5 minus 9 gives us minus 14. So that would be the result when we subtract f minus g or f of x minus g of x. And the domain is going to be all real numbers for that as well. It is kind of a technicality, but there will be a time where domain will not be all real numbers, so we want to kind of be ready for that. Okay, finally, multiplication. When you multiply two functions, f of x times g of x, that's going to be a quadratic times a linear, and that will be a cubic, so you will get an x cubed. You do have to kind of go through a tedious process of distributing. So 3x squared distributes 2x and 9. So that would give us 6x cubed, and 3 times 9 is 27x squared. And then I would distribute the 4x to the 2x and the 9. And that would give me 8x. I'm going to put the 8x squared under the 27x squared, just kind of line those up. And then 36x. And then if I distribute the negative 5, I get negative 10x and also positive 45. That should be a negative 45. I'm going to change that here in just a second. That was my mistake. So now when I add up those like terms, and that will be a negative 45, just give me a moment. I'll get 6x cubed, I will get 35x squared, I will get 26x, and once I fix that 45 to become negative, there it is, it should be negative 45. So that's a cubic, so still going to have the same domain, which is going to be all real numbers. Now you're going to find here that the domain becomes more of a consideration when you have to divide. So this function division right here, f over g, in other words, f of x over g of x. So you're going to have a quadratic, the 3x squared, 4x, and negative 5 over the linear, which is 2x plus 9. So when you divide those two functions, you do have to consider the fact that the bottom of the fraction cannot be 0. So that means the domain is going to be based on the fact that 2x plus 9 cannot equal 0. So therefore x cannot equal negative 9 over 2. So that would be one way we could write the domain. I'm going to show you a couple other ways to write that domain as well. Or at least one other way that I'd like you to write a domain that has a restricted value for x. Okay, here it is right here. So you could say that negative infinity and negative 9 over 2 is okay, and then put a union symbol and then negative 9 over 2 all the way to positive infinity. So technically speaking, that would be the official best way of writing that domain. All right, let's go ahead and look at some composition then. G of f of x, right? So in other words, we're going to put the f of x function into g of f of x. That's what that means. So now I'm going to actually write out the g function, but instead of putting x, I'm just going to put a big blank space. So 2x plus 9 becomes 2 blank plus 9. I'll put f of x in the place of x. You're inputting a function, another function. So 2 times 3x squared plus 4x minus 5 plus 9. And then you just kind of look at what you have and distribute the 2, 6x squared plus 8x minus 10 plus 9. So then you get 6x squared plus 8x, and that would be minus 1. And that would have a domain of all real numbers because it is just a quadratic. Nothing restricted there. Okay, f of g of x, same idea. I'm going to write out the f of x function, but instead of x, I'm going to put in a large blank, 3 blank squared, plus 4 times blank minus 5. So instead of x, I'm going to input the g of x function. G of x is 2x plus 9 there and 2x plus 9 here. So now I have to be a little more careful and know some things about how to square binomials, right? So here's 4x squared plus 36x plus 81. That's 2x plus 9 squared. You should really know that. Okay, I'm going to highlight that just so you remember that if you square a binomial, that would be the result. You shouldn't have to go through much of a process to do that. And then I'm going to distribute the 4. So I get 8x plus 36 minus 5. So now I distribute the 3. 12x squared, 3 times 36 is 108x. And then 3 times 81 is 243 plus 8x plus 36 minus 5. Clean it up a little bit, just get all the like terms put together. And you would have 12x squared, you got a 116x, and 274, and that would be it. And the domain is all real numbers. So we're continuing to kind of do that technicality because whenever you combine or compose functions, you want to think about domain. Now let's do g of g of x. So if you compose g with itself, that means 2 blank plus 9 instead of 2x plus 9. So I'm going to put 2x plus 9 into the function 2x plus 9. Distribute the 2, you get 4x plus 18 plus 9. And therefore it's 4x plus 27, and that's just a linear function. So notice if you compose 2 linear functions, you would still get a linear function. Okay? Linear functions are closed under composition. Okay, now these functions, this one is a fraction that's going to present a couple of different possibilities for what we can do here. So the domain is going to be based on the fact that you cannot get 14. So it's going to be negative infinity to 14 and then 14 to positive infinity for that domain because it is rational. And the domain of the second one, that's just a quadratic. So the only thing you got to worry about for that quadratic is that it is all real numbers. So there is really nothing restricted there. Or you could just say negative infinity to infinity, that would work as well. So now, excuse me. So now we're going to add those functions, subtract them, and multiply them. Then we'll look at the composition, which is going to be a little bit more complicated. So if I add them, I do have to add a fraction plus a quadratic. And when I do that, I do have to get the common denominator. So x minus 14 is my denominator. So I have to multiply the top and the bottom of x squared plus 5x by x minus 14. So it's going to look like that. And there's the common denominator. So you should never leave a fraction as 2 fractions. You should always be able to add them together because you have the skill to be able to do that. So x minus 14 is the denominator here. And then on top, I'm going to have, let's see, x squared plus 5x. Whoops, sorry, I'm going to have to fix this. That's a mistake. Let me fix that real quick. Yep, clean that up just for a second. Okay, now I think I got this. Okay, so x minus 14, common denominator. I'm going to go ahead and distribute. There we go. Distribute or multiply. You can call that FOIL if you want to. You should get x cubed. You should get 5x squared. You should get negative 14x squared. And you should get 14 times 5. That's going to come out to be negative 70x. And then the common denominator, which is, of course, x minus 14. There we go. Sorry about that. Okay, so now x minus 14 on the bottom. Combine all your wonderful like terms. Sorry about that, I'm kind of struggling on this problem. Here we go. Now I'm back on track here. Okay, x minus 14 on the bottom. You need an x cubed, you need a 5x squared, you need a negative 14. 5x squared minus 14x squared is going to be that should be negative 9x squared. I think I'm going to get it this time. Yeah, x cubed. And then minus 9x squared, and then minus 70x, and then plus 3. That is, therefore, going to be our result when we add those two up. So notice that the domain is going to be the same as our original domain for f of x. That means x can be anything as long as you do not include 14. So the best way to write that is negative infinity to 14, skip 14, go from 14 to positive infinity, and we are good for the domain. Now when we subtract these functions, when we added them, we did a lot of the work that we need to do there, just with the common denominator and everything, so I think we can kind of use that. Let me go ahead and draw a line here to kind of delineate the next part of this problem. So when I subtract these, I'm going to do f of x, which is, of course, 3 minus 14. Oh, sorry. Yeah, this is the part where I'm struggling a little bit here. I've got you covered. Whoop. Okay, now I think I'm back on track. Almost there. There we go. So we got 3 over x minus 14, that's f of x. Subtract. I'm going to put this in parentheses because whenever you subtract something that's not just a single value, you're going to have to make sure you distribute that negative. So we have x squared plus 5x times x minus 14 over x minus 14 to get that common denominator. Sorry. And then I'm going to basically just take what I already know, which is what I distributed over there. It's in blue. That's the x cubed, 5x squared, that thing. Okay, I'm just going to subtract that since I already multiplied those two together. Okay. There's some shortcuts along the way here, but a lot of this is just kind of tedious algebraic simplification, multiplying, adding, distributing, that type of thing. So now that's going to be the negative applies to the x cubed. The negative applies to that would be a positive 9x squared. It was a negative. And then finally, 70x, and then the 3 is a positive. The 70 was negative, now it's positive, so the 3 stays positive, and that's all over x minus 14. And the domain is the same, okay? So we don't have to worry about writing different domains because it is going to be exactly the same as that, okay? All right, then finally, the multiplication and division. So if you multiply these two functions, you have a rational f of x and a quadratic g of x. It's rational because it's a fraction. It is quadratic. So look at the domain of each of those, and we'll go ahead and divide or multiply first. So we're going to take f of x, and parentheses are definitely a good idea. Going to save you from making some mistakes along the way. And then we're going to take g of x, and we're going to multiply those together. Now, when you multiply two fractions, pretty straightforward. The second fraction can be over 1. So you get 3 distributed, 3x squared plus 15x, and the bottom is just x minus 14. And that's it. And notice that one more time, the domain is the same. So when you find the original domain, you pretty much end up copying it several times, so you do end up with that same domain. All right, now division. This is where we get into some things that can be a little bit more tricky or take a little bit more consideration or work. You got to watch out for that. So now, let's divide f of x over g of x. So basically, let's write a fraction such that f of x on top, so that would mean a fraction on top. So we have, let me get caught up here with my pen. There we go. So f of x is 3 over x minus 14. And we're going to divide or put that over, and then g of x is x squared plus 5x. Now, we can't leave that as it is. A fraction should always be dealt with. You should never have a fraction that is added, subtracted, multiplied, or divided without doing something with it. So when you divide, you take the original fraction and you multiply it by the reciprocal, which is 1 over x squared plus 5x. So then, if we do that, we'll do 3 on top. And we already know how to multiply those because we've done that a couple times. If you look up at the first part of the problem there, it's basically just distributing. So we do end up with that x cubed, and then we put those two together. That will come out to be negative 9x squared. And then at the end, we're going to have negative 70x. Okay, and that's it. Now, look at the bottom of the fraction. This is where we have to consider how to get the domain. So domains are easily found if you can factor. So let me factor out an x here. And once you factor out the x, you can factor the quadratic that's remaining. So notice you have x as a factor, but you can also do x minus 14 times x plus 5. So I went through that kind of quickly, but negative 9x and minus 70 should come out to look like that. And I did forget the factor of x. Let me fix that real quick. Sorry about that. So when I do the domain, let me add that factor of x there as well. So once I get to the domain, I do need to make sure that I look at every factor on the bottom, okay? So x cannot be 14, negative 5, and x also cannot be 0. So I'm going to fix that here in just a second, I think. Yep. There it is. Okay, erase, and here it comes. There we go. And I'm going to multiply by x as well. Excellent. Good. Okay, and so it's 3 on top. It's kind of a strange-looking fraction, I know, but that's what it looks like. 3 on top, all those 3 factors on the bottom. So you have x cannot be 0, 14, or negative 5. Okay, so now I'm going to write the domain in that interval notation. Negative infinity, the smallest number it can't be would be negative 5. And then skip negative 5 and go to 0. Skip 0 and go to 14, skip 14 finally, and go to infinity. So that's what it looks like when you have three numbers in a domain that are restricted. Okay? So that's a little bit more complex. We have to do some factoring and consider the values that are restricted in the denominator based on the factors. Okay, let's go ahead and do f of g of x. So let's put the g function in the f function. So that's going to mean that you write f of x, but you don't put anything in but a big blank space set of parentheses where you can put another function. So here I'm going to write out f of x. So f of x is 3 over x minus 14, but I'm not going to put x. I'm going to put blank minus 14 on the bottom. And inside of those parentheses, I'm going to go ahead and put the g of x function, which is x squared plus 5x. So that would be f of g of x. It's the f function with g put inside of it. Okay, now I'm just going to clean up the bottom. There's really not much I can do. I might be able to factor this. I hope I can, so I can consider the domain. X squared plus 5x minus 14 would be x plus 7 and x minus 2. And I factor it to get the domain. So x can be anything as long as you don't put in negative 7 or 2. So I'm going to write negative infinity to negative 7, skip negative 7, go to 2, skip 2, go to infinity. So I just basically said every value that could possibly go in here, excluding the 2 that are not allowed to go in because you can't divide by 0. Okay, g of f of x. So I'm going to write the g function, but I'm going to put a blank space because I'm going to put f inside. So instead of x squared, it's blank squared, 5 blank. X squared plus 5x is what g is. So now I'm going to put f of x inside of that. And so that means what? F of x goes inside g of x, so that's going to look like 3 over x minus 14 right there, and 3 over x minus 14 right there. So now I need to know how to square a fraction. That's pretty straightforward. Square the top, square the bottom. So that's 9 on top, and that's x squared. I think it's, what is it, x squared minus 28x. Here, you know what? I'm going to do this. I'm going to leave it as x minus 14 squared, and I'll tell you why in just a minute. So now I'm going to multiply the second fraction by 5. So the bottom of the fraction is x minus 14 squared and x minus 14. So my common denominator will be x minus 14 squared. So I'm going to leave it in factored form for the moment. Okay. So I can do this. So x minus 14 squared on the bottom. I don't really have to multiply that out. And then I'm going to do 9 plus, I'll do 15x, 15 times negative 14. And you can use a calculator, of course, if you need to, no problem with that. And then I do have the 9 that needs to get added to that. So that's going to be negative 201. Okay. When I do 9 plus 15 times 14, that 15 times 14 is negative. That would be negative 201. Okay, so that would be, it's 15 times 14, I think, is negative 210, and then you add 9, you get negative 201. Okay, the domain is just the same domain. Okay, notice that we've written its domain we're writing right now, negative infinity to 14, 14 to infinity, a bunch of times, because it was just the original domain of the function f of x. So, you know, once you get that one domain correct, you get a lot of other domains correct as well by composing and adding, subtracting, stuff like that. All right. So now let's do f of f. So f function, but don't put anything in it. 3 over blank minus 14. But in that blank, you're going to put f itself, 3 over x minus 14. So f of x goes inside of itself, and then you do 3 over. Now, on the bottom, we do have a fraction situation that needs to get added together. So 14 needs a common denominator on the bottom that is x minus 14. It's going to look like that. And then we will have 3 on top. And if you focus just on the bottom, it's going to be x minus 14 on the bottom of a fraction, in a fraction. And then on top, we do have to distribute that 14. We can think of that as a negative 14. That's fine. And then the 3. Okay, that's a positive 3. So if you kind of think about all the stuff that we're about to do on top, it's going to look like this. Uh-oh, I stopped writing there for a minute. Hold on a second, and I'll pick up where I left off, I hope. Oh, there we go. Sorry about that. 3 on top. X minus 14 is the denominator on the bottom. So it's going to be 3 minus 14x, and then 14 times 14, it's negative, negative, so that's a positive 196. Clean it up in as much as we possibly can so we can figure out the domain. So we have 3 minus 196 is, that's a mistake, hold on just a minute. 3 plus 196, that'd be 199. There we go, negative 14x. Okay, so now, again, fraction division, take the top, multiply by the reciprocal of the bottom. So the reciprocal of the bottom is x minus 14 over negative 14x plus 199. And we distribute. So now we have f of x is 3x minus 42. 3 times 14 is 42. And on the bottom, we have negative 14x plus 199. So if we look at the graph of this function, okay, the one thing we would want to focus on here is that the graph would definitely have the denominator have a value that would be an asymptote or some sort of discontinuity or place that the graph doesn't go. X is off limits there. So if you consider when the bottom of this fraction is 0, you have to do just a little bit of solving, okay? X minus 14, X cannot be, so the reason why X can't be 14 is if you look back in the problem, you'll see that one of the denominators that we got along the way is x minus 14. So you do have to consider that. 14 is excluded. And then the other value would be 199/14. So that's if you solve the denominator of our final result. So 14 and 199/14 would be the two restricted values there. Okay? And let's see. All right, so let's move on. Getting close here. Got about 10 minutes or less here. Okay, so fractions created some problems for domain, at least things we had to consider. All real numbers, unless there's a bottom of a fraction that would have a restriction. And now we have one more restriction here, and this restriction is going to be based on a square root. So you should know that if you have a square root, that whatever's under the square root cannot be negative. So x minus 2 has to be greater than or equal to 0. So that means x has to be greater than or equal to 2. In other words, you skip 2 when you consider the domain. So you would go from negative infinity to 2, like this. Sorry, I'm mistaken. You would do from 2 to infinity. It includes 2, okay? You don't have to put the negative infinity in there. You could, but it definitely is not a requirement. Okay, now, let's see. In this case, x cannot be 0 because it's 1 over 4x. So if x were 0, we would have a problem because dividing by 0 doesn't work. Okay, so let's do f of g of x then. So basically, we'll take the f of x function, which is x minus 2, square root of x minus 2, and we'll put g of x in it. G of x is 1 over 4x. Look at it, clean it up, make sure you get it to the point where you can find the domain. You know pretty much you're in good shape if you can get the domain. So just kind of look at what you got. 1 over 4x minus 2. And I'm going to go ahead and take those two fractions and combine them. So 4x being my common denominator. So what I'm going to have is 1 minus 8x over 4x. Now, if you look at this square root, all that's under a square root, any perfect square should come out. And there is a perfect square factor right in there of 1/4. So 1/4 is a factor of the thing, because 1 times 1 minus 8x, and then 4 times x would be that. So 1/4 is a perfect square, that means 1/2 should come out. So to be really the best version of this answer, you would have 1/2 outside, square root of 1 minus 8x over x inside. And if you look at the, that particular expression, there's a couple of considerations here. The first one is that definitely x can't be 0 because it's in the bottom of a fraction. And you have to consider that whatever's under our square root radical has to be greater than or equal to 0, like that. So if we solve this for x, multiply both sides by x, x times 0 is definitely going to be 0, no matter what. If you add 8x to both sides, you get 1 on this side, 8x on that side. So 1/8 is greater than or equal to x. You can also say x is less than or equal to 1/8. Either way you want to write it. So I'm going to do just what x has to be 1/8 or less is what you would write there. So x could be 1/8, okay? But it definitely cannot be anything bigger than 1/8, okay? So when you consider restricted values, just reminding that x can't be 0, okay? Because x is on the bottom of a fraction. It is also under a square root. So what we're going to do is we're going to say that x goes from 0 to 1/8, skip 1/8, okay? I'm sorry, 1/8 would definitely be the maximum, okay? And then anything else would be okay. because all those other values are less than 1/8. So what I just wrote there is x can't be 1/8 and you have to skip 0. I'm sorry, x is less than 1/8 and you have to skip over 0. Okay, because that would be off limits for the domain of that function. All right, now g of f of x. So I'm just going to basically do the same thing. I'm going to write g of x, put f of x inside of it. So I'm going to do 1/4 times blank. And instead of that blank, I'm going to put in what f of x is. So I'm going to put the square root of x minus 2 right there. Okay. That's pretty good. Let's just look at the domain. So consider the bottom of the fraction. When would that equal 0? And that's where you want to express that there is a restriction. So x minus 2 has to be greater than or equal to 0. We're going to go ahead and say greater than, because if it equals 0, you got a fraction, and that can't happen. So we'll say that x has to be greater than 2. So that's what that looks like in interval terms. 2 comma infinity means you can go from 2 to infinity, greater than 2, not equal to 2. Okay, let's do f of x. So I'm going to take the square root of x minus 2, but instead of x minus 2, I'm actually going to put in a blank so I can put f of x inside of itself. So the square root of x minus 2 goes there. And then if I try to clean this up a little bit, that's kind of a complicated simplification situation, so I'm just going to leave it alone for the moment. And just kind of think about whatever is under the square root. There is no fraction, but whatever is under the square root has to be greater than or equal to 0. So that has to be greater than or equal to 0, so I'm going to add 2. So the square root of x minus 2 has to be greater than or equal to 2. Square both sides, and you get x minus 2 has to be greater than or equal to 4. Therefore, x has to be greater than or equal to 6. So if you were to graph this, you would see something significant happening when x is 6, okay? Because greater than 6 it'll work, but everything below 6 will not work. So from 6 to infinity would be the best way to write that interval. Okay, so now we've composed, let's decompose. So if you look at a function that has a lot of operations occurring with x, like this, okay? So we're going to call this f of g of h of k of m of x. So if you look at all the operations, we're going to decompose. We're going to kind of unravel this function. So consider the operations that are being done to x in the order, kind of like PEMDAS order that we talked about before. So the first thing that's occurring with x, it's going to be that x is squared. So m is the one that we would write as x squared. X gets squared first, so m of x happens first. After m goes k, you work inside out. After you square it, you add 5, so that's k of x plus 5. So x is kind of a generic idea of input here. Okay, after we square and add 5, then we would take x to the third power. After we square it, add 5, and take third power, the next step would be multiplied by -2. And finally, f of x would be x minus 7. So that's a decomposition of a function. Okay, let's look at the next one here. M, the first thing is either sine or sine squared. We'll go ahead and just do sine squared, even though technically sine and squaring are two separate operations. Okay, we can call m of x sine squared of x. After you do that, now we're going to take a 2, okay, and we're going to, here we go, 2 minus whatever you just got, 2 minus the sine of x squared. You can also write negative x plus 2 because that does the same thing. So that's k of x. H of x, going in order, is going to be square root of x. After you square root it, to get g of x, you would multiply by 5. And finally, the last step here, if you were going to do an order of operations, would be f of x, which is x minus 3. So there's the decomposition of those two functions if you were to decompose them that way. All right, let's look at another way you can look at composition here, a table and also a graph. Okay, so we'll go through this pretty quickly, just a couple minutes here. All right, so x, f of x, g of x. It's in a table, so it lists out all the inputs and outputs. So let's look at f of x, g of x given x. So f of g of 1 means you put 1 into g first. Input output is what we're doing basically here. So f of g of 1. So first find g of 1. So if x is 1, okay, I marked the wrong table there. X is 1, g of x is 0. That's a mistake. There it is. That's the one I want to circle. And so therefore, then you take that 0 and you put it into f. So if you put 0 into f, you would get -1 out based on what that table says. Okay, now f of g of -1. So take g of -1 again. That's 0. Take f of 0. And f of 0 is definitely, if you look at the table, going to be -1 also. g of f of negative 1. So f of negative 1 is going to be negative 2. So g of negative 2, and if you take g of negative 2, you would get a 3 according to the table. Okay, so input negative 1, output negative 2, and you get a 3 as your output. G of f of 0, so if you put 0 into f, you would get negative 1. If you put negative 1 into g, you get 0. G of negative 2 means g of 3. Negative 2 goes in, 3 comes out. 3 goes in, 8 comes out to g. Okay, f of negative 1, you would get a negative 2. And f of negative 2 comes out as a negative 5. F of negative 2 is negative 5. Okay? Feel free to pause or slow it down. I'm going to go through this a little bit quicker. Now, if you use a graph, you get the same information as you did on the table. So look at the g of x graph on top. It's kind of the curve, and then the f of x is more of the linear, looks like an absolute value type of graph. So g of f of negative 1. So negative 1 goes into f, and you get a 1 out. So g, it takes a 1 in. So if you put 1 into the g function, you would get a 6 out. So negative 1 in, 1 out, 1 in, 6 out. Okay, g of f of 0. So first you find f of 0. That's 0. I'm sorry. F of 0 is going to be 0. Sorry, f of 0 All right, I'll probably have to go back and look at those graphs and help you fix those in class, okay? Sorry, that was a little bit quick. Okay, finally, let's go ahead and do f of g, f composed with g. So that means in this particular case, it's going to be 2x plus 5 on the square root. That's our domain. So I'm going to go through these quickly. I'm just going to write down the answers for A, B, C, D for this last one. And then if you have some questions, you can let me know. We can go over those, okay? So here come the answers for that. That's the fourth root of x. Domain is that x would be greater than or equal to 0, and then g of g. All right, so we'll recap this when I see you guys in class here. So again, thanks for your patience on that. I apologize. I will try to make sure my videos get a little bit better. So I will see you soon.